The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon or good morning from wherever you're calling in from. Welcome to the third in Greener U's webinar series. This one's on greening your lab. My name is David Adamian. I'm the Vice President of Engineering and Operations at Greener U, and I will be your moderator today. We put together these webinars to give us a place to talk about ideas with colleges who may be interested in seeing how to address various sustainability-related issues. And again, today we're going to be focusing on laboratories. We're doing this over the computer. One of the ways we keep order is that we keep everyone muted, so no one's going to be able to hear you if you speak. But we do want to have an opportunity to get input from you, so you've got the ability to submit questions online, and we will be taking questions. We'll be addressing questions at the end of the webinar, so feel free to submit them at any point along the way. We will do our best to end by 12:45. We don't want to take up any more of your valuable time than necessary, so we're going to try to move right through this efficiently. Speaking today, we've got Bill Spratt, the Director of Facilities and Operations from Worcester Polytechnic Institute, Brandon Geller, FAS Green Program Manager from Harvard University, and Quentin Gilly, Lab Sustainability Coordinator from Harvard. We're going to talk very briefly about Greener U and our approach to labs, set the stage for these presentations by talking about some of the challenges that are common to labs, and then each of the two institutions are going to provide a brief presentation on their work in laboratories, and we will leave about 10 to 15 minutes at the end for questions and answers. Again, briefly about Greener U, we are a firm that works exclusively with colleges and universities. We have an integrated approach to sustainability on college campuses that's rooted in deep energy efficiency expertise, but also recognizes that decisions on these campuses are made in complex, multi-stakeholder environments. We focus on understanding the culture of each institution and crafting approaches that are really designed to fit that culture and work best within that culture. We also recognize that behavior is critical when addressing energy and other sustainability issues. Behavior of maintenance staff, students, and building occupants can really impact building energy use, and so we craft programs and approaches designed to address behavior as well. So today, again, talking about labs, there are a number of types of challenges that are pretty common to labs that we want to address in these presentations. Safety is first and foremost. It's really central to everything we do and we think about when working in labs. Ventilation requirements, which are the main driver of the high energy density that we find in labs, is safety driven. You know, it's all about exposure control. So our work in energy efficiency is intimately entwined with safety considerations in these labs. And performing any work in a laboratory environment, folks working in the labs have to be cognizant of the fact that they're working in a hazardous environment and the attendant constraints that creates. There's critical research that goes on in most laboratory facilities. Disruptions to service under the best of circumstances are difficult to coordinate. So being sensitive to that and flexible in how you work in these labs is critical to getting anything done in this environment. And again, as we discussed in Greener U's approach, behavior really matters, you know, especially around fume hoods, but also around labs. And use of other lab equipment, you know, the researchers and other people working in the labs, how they interact with the systems in those labs really matters and can have a big impact both on safety and on energy use. So with that context, we're going to jump right in with Bill Spratt from Worcester Polytechnic Institute to talk about a program that they've recently completed. Bill, take it away.
Thank you, David. My name is Bill Spratt. I'm Director of Facilities Operations here at Worcester Polytechnic Institute, or WPI as most people know it. Today I want to talk about a project we did at one of our largest, or at the largest lab building on campus. And so far it's been an extremely successful project, and it's basically focused around fume hoods. So that's going to be the focus of my topic today. I'll get into some lessons learned along the way. So let's first start out with the why we did this project on campus. So WPI has a sustainability plan. That plan involves lots of things on campus related to sustainability, but one of those components is energy management. And with that, we also partnered with Greener U and 3 other campuses in Worcester to put together a program with the utilities, National Grid and NSTAR utilities here in Worcester. And essentially what we've done is made a commitment to reduce 10 to 15% of our campus energy use. And the way we go about that is the utilities have incentive programs, which most everyone is aware of. These were enhanced programs where we could get more incentives than the traditional incentive programs for specific buildings. And the goal was, if we could take specific buildings and reduce the energy load by 20%, we'd be eligible for those enhanced incentives. And those enhanced incentives could range from 50%, which is fairly typical, up to almost 80%. So it was very attractive to get these projects underway. So we secured some money essentially some seed money to start these projects, and we started looking at the opportunities for the buildings. As you can see on the next slide, the reason we chose Gateway Park was Gateway, you can see on the left-hand side here, the spreadsheet, Gateway is by far the biggest energy user on campus. So it offered a lot of opportunity here. With the Synergy program and what Greener U put together, they also modeled different buildings and different campuses and compared us to each other so we'd know where we stood. And you can see on the, I'm sorry, that one was on the right-hand side. On the left-hand side, you see the circle at the far left. Gateway Park is the highest square footage and energy user and trends higher than most other laboratories that we looked at within the 3 campuses. So Gateway Park is about 125,000 square foot building. It consists of state-of-the-art laboratories. It's primarily used for life sciences and bioengineering for graduate education and research. There's also a partnership with private vendors that come in. They rent space as well, but they're heavy lab driven. It's a 4-story building, and about 2/3 of the building are laboratory space, with about 40 fume hoods in the building. This is the process that we took for this building. Again, the heavy partnership was WPI, Greener U, and National Grid. We also had in partnership working under Greener U a company called ECT, who is a laboratory hood expert and had a role in developing some of the Z9.5 standards for laboratory ventilation. This project, there was an assessment that went through for some auditing to figure out if this was a candidate for a good project. We had design and materials for the project, implementation of the project, monitoring, and then continuous optimization of the project as well. So in the assessment phase of this project, you can see with with Gateway Park, we had an energy model for the building. The total energy use in this building broke down, and you can see almost 2/3 of that building was energy from space heating and cooling. So that's a major issue when it comes to fume hoods, because essentially you're taking conditioned air and sucking it through the exhaust hoods and blowing it out the roof. So whether that's heating or air conditioning, it's a big challenge with the building. So this really bubbled up as one of the top initiatives for this. It was a multi-phase project. We identified 12 major measures to do and estimated the savings at about 22%. So we met our 20% goal if everything went through. So at this point in time, we just had an estimate of 22% savings on the building, and I'll tell you towards the end what we finished out at. So part of the assessment was lab ventilation and safety. So when a building is designed, I think traditionally it's a very conservative approach when it comes to labs about how many air changes per hour a lab can handle. An engineer or an architect would typically just have a space in mind and a volume of air in that space and air changes. But anybody who's operated a lab knows that once the building gets started, when you get lab benches and the fixtures in there and all of the lab equipment, the volume of that space really is reduced heavily. So even if an initial design is to have, say, conservatively 12 air changes per hour, as you bring stuff into that lab, that volume goes down and your air changes go up. When we did our evaluation of this building, we realized that there were some of our spaces that were getting 21 air changes per hour or 14 air changes per hour. You can see those in the circled spreadsheet there. So the Z9.5 standards say with proper planning, you could have as low as 4 air changes per hour. So doing our assessment, it was really important that we got the professionals involved. That would be a laboratory ventilation safety specialist, as well as the building occupants, very critical part of this process, our environmental health and safety people, and evaluations of each of the processes. So this is probably the most critical part of this project, and I'll talk about this at the end as well. WPI's EH&S was critical. Department heads were critical. The research that goes on in this building ranges from very benign work in labs to very dangerous work. So getting everybody involved from the get-go was critical. So stakeholder involvement was absolutely essential to this project. So as you can see on the next slide, the stakeholder involvement went from assessment of the different buildings and labs, walking focus groups. So we took the principal investigators of each lab, walked through the labs with them, got their feedback. There were a lot of real challenges at the beginning with safety. We wanted to make sure we were providing a safe environment. So what started out as an energy management project really grew towards a safety project. Because even if you have lab space that has too much ventilation, you can have turbulent airflow and actually push some of the fumes that you're trying to contain out into the space. One of the things we did as well was an ideation session where the lab stakeholders got to choose the look and feel of how the lab hoods would look at the end of this project. So this is the sign design. This is an example. They wanted it to be more science-y than traditional WPI logos, and they wanted it to be more modern. So this was a simple, everyone was given stickers and just put the stickers on the board. It was very low tech, but very visual in nature of what people wanted to see. So the air balancing, we talked about the Z9.5 standards. So you saw on a previous slide that we had up to 21 air changes per hour. So we had an opportunity to reduce that ventilation, but also do it in a way that we could mitigate the hazards. We developed new airflow specs with environmental health and safety and with the stakeholders. And essentially what we determined was that we could really have hoods with 3 different levels of exhaust. And we've labeled them as such. So there are hoods that have a higher flow from dangerous chemicals and a lower flow for more benign chemicals, all of them within safe ranges. In doing that, we were able to dramatically rebalance our supply and exhaust. And one of the things that came out of that was we had a static pressure design of the building of 2.25 inches of water column. And we were able to reduce that a full inch of water column to 1.25 inches. So essentially what that means is we had to bring in less air to the building, and we're exhausting less air. We had 4 exhaust fans on the roof to serve this function. 3 of them were running at 100% all of the time. By the end of the project, we were able to reduce the number of fans running to 2, and we had 100% redundancy in our fans. So it really was an important safety factor there. As you can see on the next slide, the fume hoods were a focus of this project, and what we did was essentially add controls to the fume hoods. The original fume hoods essentially had a slow and fast speed. It was a 2-position controller. So when the fume hood was closed, it would have less flow. When the fume hood was open, it would have a high flow. There really wasn't any balance in between there. So we were able to install variable air volume controls, VAV controls, that could sense the position of the staff and the sash and adjust the airflow accordingly. Before, there was no horizontal sash sensing. Now we have that. We increased the safety of the fume hoods. Before and after, we tested before, we tested after, and we had a much safer condition in the after. You can see in the small graph to the left-hand side shows some before and afters of 2 different hoods and how their air volume dramatically dropped in the process. Other pieces of this project were controls. So we found in the evaluation failed sensors and things that were a challenge in the original design of the building, so we were able to fix some of that deferred maintenance and able to control it better. We reprogrammed a lot of our controllers and updated occupancy scheduling, and the bigger piece of the dollar savings was in the dynamic static pressure reset. Some of the other work that we did on this project, as you can see on the next slide, was installing 2 75 kilowatt cogeneration engines. So these engines run and spin a generator, which creates electricity. The engines create heat, and we use that heat to offset our boiler heat load, and that really is a summer and winter load. In the winter time, obviously, it's for heating the building. For the summertime, it's for controlling HVAC, humidity, and resetting some of the water set points. So we were able to use that heat year-round. In addition to the cogen, we had lighting updates going from fluorescents to LEDs, and also to enhance our lighting controls. Other pieces of the work were continuous optimization. We are currently monitoring about 1,400 building automation points, and this is just to show failures in the future. If we have actuators or dampers that aren't opening or closing properly, we'll be able to identify that. This is part of what Greener U offered, and also what National Grid wanted to see in continuous monitoring for 2 years. They required that as part of the incentive program, and this was the program that we put in. So we can detect faults. We're going to review that quarterly moving forward. So bottom line, our results. The graph here is showing our before and after. The main part is we have a much safer building now. So that was kind of an unintended consequence. We knew fume hoods were important, but we didn't realize that doing an energy efficiency project could actually make our building safer. So that's great. We have happy customers, which was, given the first few meetings we had and the questions that came up, we were wondering if that was going to happen, but we really did have a lot of input from the stakeholders, and truly happy customers at the end of this project. And we exceeded our targets. We wanted a 22% reduction. That was what we estimated, And for the 2 months that we've been commissioning so far, we have a 33% reduction, beating our targets. And at the largest energy user on campus, that represents, with this building and another building we did at the same time, about a 11% reduction in our total energy use and about a 7% reduction in our greenhouse gas emissions just with these 2 projects that we did. So as far as lessons learned, the lesson that came out of this, again, unintended, was the focus was on safety. This was not necessarily an energy project. This was a safety project that had energy results. Getting buy-in from all stakeholders was a critical part of this. We had a lot of objections in the beginning, but getting the stakeholders involved from the beginning, getting them to understand the process, they became advocates. It was a great collaboration. Communication is essential on this. This is a 24/7 building with research that dates back 4 years at times. So losing any part of their research is unacceptable. We can't have that. So this involved a building shutdown. So coordinating those shutdowns was really important. And the date we chose for our shutdown happened during one of our campus breaks, which would have a lower usage. It also ended up being the coldest day of the year. I think it was somewhere around 4 degrees, and we were doing a 6-hour building shutdown. So we ended up doing the shutdown, and everything worked splendidly, but I think given the choice again, I would have had 2 or 3 dates. So if something came up like weather or those type of things, we could have chose another date. The controls of a building, how a building's set up from the beginning, there's opportunities there, and really looking holistically at the entire building, you will find things that you didn't realize. And one of these things was in the fans the exhaust fans I talked about. We really had a failure point in our system. If one fan failed prior to this project, we would have been out of business. Now we have redundancy in that, and that really wasn't found until that investigation started. Trialing lighting retrofits, we did have mock-ups at the beginning, but one thing we didn't realize is the system that we were going to put in to retrofit our existing lighting didn't fit very well inside the existing fixture. So we probably should have tested that at the beginning, kind of a lesson learned there. And certainly finding the right partners. Greener U was a great partner in this and really led the project management and kept us in the loop the entire time. Also ECT, getting true professionals in the trade. You need to get people that know their stuff. Even though here in facilities we have expertise, there's more brains if you can pull more people into the project. So that's essentially it. Thank you for your time.
Thanks, Bill. That's very interesting, and we'll be taking questions on that at the end. But right now, I'd like to pass it over to Brandon Geller, Faculty of Arts and Science Screen Program Manager at Harvard, and Quentin Gilly, the Lab Sustainability Coordinator, also at Harvard.
Hi, I'm Brandon. I'm Quentin. We're very excited to be here. We're excited. We're looking forward to sharing some of the things that we do over at Harvard with you all. I'm required really quickly to sort of say that by Harvard's trademarking office, that Harvard doesn't endorse Greener U or their products, yada yada. So just FYI. Now if that's out of the way, we can get started. So if we can go to the next slide. There we go. So putting this all in context really quick. So we said Faculty of Arts and Sciences. We are one portion of Harvard's lab environment. So we sort of are the college and the Graduate School of Arts and Sciences, and we have colleagues that work specifically on the med school. So just sort of an FYI about sort of our entire context here. So we're just going to focus a little bit on what we do here at the Faculty of Arts and Sciences. But Harvard has been sort of in the sustainability game for many years. Our first program was back in 2002 with a student outreach program. And since then, we've spread out into many areas, such as labs, also offices, and many other parts of our campus. So putting it into context, we've had a greenhouse gas goal since 2008 of trying to reduce our greenhouse gas emissions by 30% below 2006 levels by 2016, which is getting precariously close. So we're working on that. But even looking beyond that, we're developing a holistic sustainability plan right now that looks not just at energy, but also at waste, at purchasing, at indoor air quality, at food, all those sorts of things, transportation. And we're hoping to sort of roll that out in the next few months. So you should be seeing something about that. But we're approaching sustainability from many facets. We even have a green building standard. So that our buildings are required to, if we have new construction, it has to be at least LEED Gold, must meet certain energy standards, that sort of thing. So really, there's a large culture of sustainability on campus, and we're trying to infuse that as much as possible in a number of different areas. That said, coming back to our topic, labs are a big part of that, as you heard earlier.
So yeah, as we've discussed, Harvard is a research university, so about 23% of our square footage is devoted to lab space, but 49% of our energy use goes towards the same lab space. So this really pointed out to us as labs being an area for us to focus on. So as you can see on the next slide, we have 5 ways we're looking into this.
Yep. So as you'll see, we have sort of 5 ways that we sort of want to tackle this, or at least our best practices from our experience. So the first is start with energy. Just as you saw with WPI, fume hoods, that's where they went, the biggest energy users on campus. Same here. We started out with fume hoods. Our first lab programs were all about fume hoods, and now with our sort of Shut the Sash program, we estimate about $250,000 a year in avoided energy costs. So it's big. It makes a difference. And that feeds right into the second one. Focus on payback, cost savings. Our program works by us being paid out of operations. So operations pays for us to sort of work on environmental issues, and but because of that, so we sort of have to justify our costs. So we justify it by showing them energy savings, by showing them waste savings, reducing the amount they have to pay for waste reduction and disposal, that sort of thing. So it sort of feeds back into energy being one of the easiest ways to sort of justify that. Meeting researchers where they are. So this goes back to a lot of what WPI talked about and Greener U talked about. We don't want to get in the way of research. That's important. We don't want to stop them. We don't want to interrupt them or anything. And they have important things to focus on. I can't stop them from trying to cure cancer like that. We don't want to do that by any means. So we're trying to meet them where they are. So we try and incentivize them, make it worth their while to sort of work with us. And along those lines, we sort of create tools for them, opportunities to really sort of make it easy for them to do these efforts, and really sort of seem like we're providing a service to them. And lastly, collaboration. So this really ties back very well into what, nicely into what WPI was saying. Working with environmental health and safety on fume hoods, like sort of hitting it not only from the fact that these things will save energy, but they also make the lab safer. You're creating a better environment for the people there. So really getting that sort of 1-2 punch of they're not just hearing about it from us, but they're hearing about it from environmental health and safety as well. And really sort of, once again, hitting the entire culture and creating this culture around it. So we'll give another example beyond fume hoods on the next slide. So ultra-low temperature freezers, commonly known as -80. So going back to the idea of focusing on energy first, once you get past fume hoods, we've sort of found that ULTs are the next big energy user in most labs. How much is it, Quentin?
So we've been researching different models, and we found that these freezers can use anywhere from 16 to 22 kilowatt hours of electricity, which can end up being around $1,000 a year per freezer.
Yes. So big energy user, right? Our colleague about 3 years ago started studying this, looking into this further, and really found, reading up on best practices and whatnot, And one of the things that she found is that if you clean the coils on these freezers, they operate more efficiently. So she worked with a local vendor to create a coil cleaning program where they gave us a set price for doing a bulk number of these and would come to campus and clean coils twice a year on these freezers. Operations agreed to pay for it because it would save more energy by having efficient freezers than it would cost to actually pay for the cleanings. And then we set all this up, and then she started coming to the labs. And going back to that sort of meeting them where they are and creating tools, we offered this as a service to them, promising that it'll prolong the freezer life, it'll increase sample security because freezers won't be going down, they won't have to worry about the freezer breaking suddenly. And we also negotiated with the vendor that at one of those 2 coil cleanings, they would do just a general service check of the freezer. So they would look and say, oh yes, the gasket is broken, or your coil, like one of the coils isn't working, or compressor looks like it needs some service, that sort of thing. And they would just sort of write this up and give it to the lab. So the lab knew that they needed to do an extra service. And from then on, it would be up to the lab to actually do that. So we weren't paying for the actual repairs, but we at least gave them the information and provided a service to them, provided they were willing to sign up for our preventative maintenance program. The next tool we sort of offered from there were these de-icing kits, and Quentin will cover that a little bit.
Yeah, so labs at Harvard are offered a de-icing kit for their ultra-low temperature freezers, which include a rubber mallet, which the lab members can use to kind of knock the ice that builds up around the gaskets to free the ice from around the door, so that way when the door shuts, it creates a better seal. The idea that if the seal is better, the compressors won't have to run as longer and the freezer lifespan will be longer. We also provide ice scrapers to help remove ice from the interior doors for the same reason. And we also provide a pair of insulating gloves to kind of make the whole cleaning process a little safer. And we also give them a magnet that they can kind of put on their freezers just as a reminder of best practices and information like that. So as you can see on the next slide, we're doing some more studies with freezers, kind of checking different brands to see which freezers are more efficient than others. And we found one brand called the Stirling engine, which uses a helium piston technology instead of a more traditional cascade freezer. We brought one, to one of our buildings, tested it for a while, and we found that it uses about 7 to 10 kilowatt hours per day, which is much lower than, like I mentioned before, the other freezers using 16 to 22. So we use our energy fund to kind of incentivize the purchase of these freezers. So every lab at the Faculty of Arts and Sciences that wants to buy a Stirling engine will get a $3,000 rebate from us. So this will bring the price of the Stirling's freezers down to about the same as other ultra-low temperature freezers. It ends up being a win-win for all because the Stirling technology actually allows for more interior space to store samples, and then we get energy savings. So the payback on this incentive is about 7 years through the energy budget. And we have about we have 5 of these on campus now, and we have 3 that are in the process of being purchased. So as you can see on the next slide, we also feel that sample organization is important for energy savings in freezers. So we provide tracking information for freezer samples for labs. This can be as simple as just a map they can post on the door with a quick guide to where different researcher samples are. Or, some labs, they can use a spreadsheet macro to kind of help search for different samples. So this will make it easier for when the researcher goes up to the freezer and opens the door, they don't have to kind of stumble around as much as they would. They know right where the sample is and they can close the door immediately. So we also encourage defrosting of the -20 freezers. As you can see in this image here, ice buildup is particularly bad in this freezer type. So it can end up taking up a lot of space and reduce the amount of space for the samples. So we encourage regular cleanouts and better organization. And by going through these defrosts, it encourages the labs to kind of sort through older samples. You know, sometimes someone can leave from a lab, they'll leave samples behind, and if, you know, 2 or 3 years go by, they may not remember what they are, and people are kind of afraid to get rid of the samples because they may be important. But as long as people defrost these regularly, they can, you know, see these samples and identify them quickly. So as we move to the next slide, you can see that we also do more than just freezer programs.
Yeah, so moving beyond just energy savings, there's also, just to give you a little bit better idea of sort of the breadth and of opportunities, we also try and promote reuse on campus and reduce waste. So one example of that is our lab-oriented free cycles. So we'll encourage reuse of lab equipment. Now this goes back to the point of working well with EH&S. So double checking with EH&S whenever a lab is being, you know, decommissioned, you know, a lab manager or professor is retired, and double checking like what equipment can be reused, and then collecting that together. Or if a lab is cleaning out their own stuff, say they don't do a certain type of experiment anymore, getting them to clean out their space. And we gather this stuff together about twice a year and make it available for other researchers to come and take it away at our free cycles. We also encourage sort of office supplies as well. And all of that sort of goes back to providing a service. So we're providing this equipment. It's less stuff that they have to buy, that other labs have to buy. And you're making it easy for labs to sort of clean out their space in a guilt-free way. So that's one method. Another is we have sort of an online reuse list. And this is sort of our Craigslist for lab equipment. And you can check it out at green.harvard.edu/labs. And basically people can, you know, especially lab equipment that's too big to bring to a free cycle, they can post on our reuse list saying like, hey, we have this, you know, I have all this glassware that we're not going to use anymore. If you would like it, please email me, and, you know, people can trade off things like that. Lastly, we have a reuse room. So this is we actually have 2 of them actually, one at FAS and then one over at the School of Public Health at Harvard. Basically, we try and centralize one location where people can bring down some supplies that they don't need anymore, some equipment that they don't need anymore, but also make this a space where people can bring a number of other things. So we work with facilities to get a space, and then we'll have things there like electronic waste recycling. We'll have collection areas for printer cartridges that are going to go recycling. We've worked with a local vendor to collect gel packs, so the cold packs that come with samples to keep them cold, to collect them there, and then the vendor comes and takes them away and reuses them. Working with styrofoam packaging, so styrofoam shipping containers that if they come with a return envelope, we'll collect them there, and mail services will pick it up and send it back for us. As well as we just installed a milliQ filter recycling container where the company will send the barrel, and once we fill it up, we have to pay a one-time shipping cost to send it back. So working to sort of make that all one centralized location, a one-stop shop for people to get rid of their waste in a sustainable way. And this is just sort of, so this makes up our sort of quick snapshot of a few of the things we're doing. We're happy to talk about other things that we're doing or to go more in depth with these. But we will turn it back over to David.
Okay. Thanks, Brandon and Quentin, and thanks again to Bill for your presentations. We're going to open it up now to questions and answers. So feel free to type away, send us your questions online. We've got a couple already that we'll dig right into. First one relates to engagement strategies. Both presentations touched on engaging the users, engaging the occupants of the labs. There was discussion in WPI of walking focus groups and ideation sessions and some discussion around the concept of meeting researchers where they are in the Harvard presentation. So this questioner is asking for a little bit more elaboration on those strategies. And Bill, rather than throw this one at you, I've got Dallas Scott, our Director of Change Management, in the room here to talk a little bit about some of the work that that we did with WPI, and then I would love to hear from Brandon and Quentin as well.
Yeah, thanks, David. So when we're looking at the lab space and focusing on our change management approach, we really are focusing on our foundation of behavior change theory. We recognize that there's two goals that we keep in mind during this process of engaging stakeholders. One is managing the infrastructure and technology changes that will be occurring and recognizing the impact that might have on both the occupants and the building operators. And so we're constantly doing small check-ins along the way to do slight edits and variations to our process as we go through that in order to not have any sort of big barrier at any point in time. It's much easier to do those little check-ins. And then, and second of all, bringing in the stakeholders, the people who work in these buildings are experts of their buildings. They probably spend more time in their labs and in their offices than they do their own homes. And so one is to show respect of that space, and the other is to recognize that they are going to know how that space is actually used. And we want to know the true story. For us to change the both infrastructure or technology of the building without knowing the reality of how the building is used every day, we won't actually be addressing the real issues there. And if we don't bring the occupants along the way, they'll create their own story of what they think is happening in that building. And we call this attribution error in behavior theory. So in order for us to provide them with a fuller picture of what's happening and bring them along the whole way, we find that the entire process is much more enjoyable and smoother for both parties, the operators, facilities, lab users, everyone all together.
Great.
If I could just add a couple
Brandon and Quentin, again, you mentioned meeting researchers where they are. Any elaboration you can provide on that and how you approach that?
Yeah, although it sounded like Bill had a couple things he wanted to say before we go in. Is that...
Thank you. I'll be real quick. Two things. Make sure you get stakeholders that have the horsepower to drive the project. So you need to really get buy-in from the very top of the organization all the way through the organization. But if you have, say, the principal investigators in a lab, they might not have the authority to make decisions. So make sure you get the decision makers at the table. And also, don't waste people's time. Just don't have meetings just to have meetings. These people are taking the time out of their day, so be concise and thoughtful of their time. So that was just my 2 cents on things that worked well here at WPI.
Cool.
Great, thanks, Bill.
Yeah, no, absolutely. I think both Bill and Dallas they have good points. Small check-ins, making sure that, you're bringing people along. Don't dictate to them what you're doing. Don't make sure you're checking in with them about this process, because as Dallas said, they'll make up their own story about what's happening. If we just had somebody coming and showing up and going into people's freezers, they would not be too pleased with us, but rather bringing them in on this. I think going beyond that, just in sort of on the more fun side, say with our Shut the Sash program, we've sort of tried to incentivize things in some ways. So say with Shut the Sash, we create goals for all our labs, and then if they meet their goals, they're entered to win a beer and pizza party. It's easy to do. Grad students are hungry. Know your audience. So we sort of incentivize them to want to participate that way. And it's been fairly effective over the last few years. Any thoughts, Quentin?
And yeah, we're able to, especially with our chemistry department, we're able to customize goals for each of the labs based on their usage, because we have an active monitoring system for when hoods are open and shut, so we can see, what's the cubic feet per minute of different labs and kind of help set a reasonable goal for them to keep the sashes shut.
Excellent. Thank you very much. We got a couple of questions here relating to the Stirling freezers, so I'm going to sort of combine them and turn it over to Harvard to address them. There's one where participants commenting that they attempted to purchase a Stirling freezer, but the feedback they got was they decided not to go forward because it's a new technology, a new company. They weren't convinced of the staying power of the company and the ability to get replacement parts and service. And the other question relates to the paybacks that you mentioned. Just asking for a little clarification. Was that based on just the cost of the freezer? Was it based on the rebate that facilities was paying out? A little elaboration on that.
So to the point about the parts and maintenance, before we started enacting this program, we did check with the same vendor who's doing our repairs and coil cleanings. We checked to make sure they were trained on repairing these freezers. And so the company that we worked with for purchasing the Stirling, worked with them and made sure that they were trained, and they have, it is a new technology. It's not super prevalent. But the vendor does have one person who is trained on the Stirling, so he is ready to make those repairs and do that if it happens. I think we've had one issue with one freezer having one problem, but it was small, and the vendor came out to repair it. I think they did have to wait a few days to get the parts, but there is the point, because it did have to be shipped. But it still, was under warranty, all that stuff, so it was at no cost to the end user for that. But that's the only one we've had so far. And then, Quentin, do you want to cover the energy?
Yeah, I was just going to say also that the new technology has a lot less moving parts than a traditional compressor system, so we feel that it's worth the investment, and we have some faith in it at this point. So we're still moving forward with it, trying to get them in our labs. But to meet you, you had a question about the rebate. So basically, the $3,000 that we give to each lab that purchases a freezer, that covers the additional costs, because the Stirling engine is more expensive, and we negotiated a price with them and looked at our negotiated prices with our other freezer vendors, and we came to the conclusion that a $3,000 incentive would make it is reasonable for the lab. So so by giving the labs $3,000, they also get the additional square footage. But when it comes to the payback, the payback on the freezer is basically what covers our $3,000 incentive. It doesn't cover the whole cost of the freezer. It's just that additional $3,000. So if you divide $3,000 up by 7 years, you will make your money back in energy savings.
Got it. Thank you. Next up, we've got a question for Bill about the relationship with Greener U, and I guess more broadly the project overall. How was the project funded?
The project was funded. It was really 2 projects and 2 buildings on campus. So I'll talk about the 2, but the bigger part of the project was the Gateway building. But so the project was funded with an investment from WPI. The paybacks on the project were very good. So I guess just to speak in real or close to real numbers, this project was about a $1.8 million project in total. The utility incentive for that project was about $1.2 million. So WPI was left with approximately a $500,000 investment to make, which we did. The payback on that investment was Rob, you might know it was under 3 years. I want to say 2.6 years total payback on investment for this project. So to reach our energy goals, it was an important thing to do, but the project relied heavily on utility incentives. So utility incentives really drove this project, and we had the increased incentive with the partnership of Greener U and the other 2 colleges in Worcester.
Okay, great. Thank you. Next question. You've talked a lot about how making labs greener can make them safer. Can you be more specific about how the labs are safer? I'll toss that one out to Bill first and give Harvard the opportunity to chime in as well.
Okay. When we did our lab hood assessment, we realized that a lot of the labs were doing up to 21 air changes per hour. And by doing that, you had a lot of air going into those hoods constantly. And what that can create is a situation where the air gets turbulent inside the hood. So say the air rushes in, bounces off the back wall of the hood, and then has the potential to bounce that air back out into the lab. So by balancing these, testing these individually at every single hood, we had great results on the face velocities and making sure that the air coming in from this space takes the fumes from the chemicals that are in the hood and sends them up the stack. All of them go up the stack, as opposed to if you have some spill out from a turbulent airflow. So we did follow-up testing through this project, and we also did it through our environmental health and safety. And the Gateway project scored very high on safety of the hoods after the project. So that's why the safety increased. These lab hoods are doing what they're supposed to do. They're taking the chemicals and putting them up into the atmosphere, as opposed to having the potential of spilling it back into the room.
Thanks, Bill. Before turning it over to Harvard, I think there's a little bit of a follow-up I'm seeing here that relates to that question. You talked about the 3 levels of exhaust, and one participant is asking for a little bit of elaboration on those 3 levels of exhaust.
I'm here with Rob Durning from Greener U as well, but essentially that is based on flow. For hoods that had maybe organics or basically dirt or things like that, we had a lower velocity of air or a lower turnover in air in that room. Where some of the other hoods, there are very dangerous chemicals at use, and those hoods had a higher rate of airflow. Does that sum it up, Rob?
Yeah, that touches on it. There were certain floors in certain areas that had heavy chemical use where we balanced those hoods to a higher minimum flow set point, and the more of the biology-based labs went to a lower minimum flow rate. They all operated at the same face velocity when the hood opened, but this was more to make sure that at a minimum they were going to be safely exhausting whatever volatiles were created inside that hood.
And the hoods are labeled as such. So essentially you have a green, yellow, red labeling system that will be reviewed each year, because labs do change over time, and we need to make sure that the level of those labs, those fume hoods, change appropriately.
Great. Thanks, Bill. And again, the general question about safety, Harvard, if there's anything that Brandon and Quentin want to add to that conversation?
Yeah, we can give a few other examples beyond the fume hood of ways sustainability has sort of gone hand in hand with making the labs a little safer. One example is we worked closely with EH&S to do reusable biohazard boxes. So instead of the old, the cardboard ones that people throw things in, those had a tendency to, obviously they're being disposed of, so that's waste, and adding to landfill and whatnot, or not landfill, Incineration. Thanks, Quentin. But they also had a tendency to leak. So we worked closely with EH&S to sort of pilot these reusable ones that were sturdier material, and they get cleaned, sterilized, and then returned back and used again. But that reduced the amount of hazardous chemicals being leaked into the lab, and cleanup procedures that had to be followed through on that. We've also been working on biosafety cabinets. You want to cover that one?
Yeah. So we're looking into the concern with the UV lights with our biosafety cabinets. They may not provide as good a sterilization as some researchers believe they do. So we're thinking about unrolling a program where we kind of encourage people to not rely on that and focus on traditional sterilization with a 70% ethanol solution or bleach or something, things like that. And that also makes the lab safer because there's less exposure to UV light, causing burns and things like that. So.
And promoting good lab technique as well. So working with EH&S on that. So we saving energy on the UV light front and promoting good technique on the other side. So those are just two examples.
Okay, thank you very much. We are running towards the end here. I'm gonna throw out one more question, and then we'll wrap up. And again, I'm going to combine a couple of questions that we've got here, and I apologize that we're not getting to all the questions here. We will do our best to follow up on those, and certainly feel free to email us if you have additional questions. Got two questions here relating to the reuse and surplus. One is, it's very difficult for busy people in different departments and buildings. How do you make this big and systematic? What would your ideal web functionality be, et cetera? And second question, are there any issues with the reuse of equipment from granting agencies? Are they concerned that they've given money to one lab and then another lab, and it ends up being used, the equipment ends up being used for a purpose other than the grantor intended?
Those are good questions. Just to the second one, that's a really good point. So oftentimes with, say, capital equipment, we have to make sure to, before it gets used somewhere else, we check with many departments, we check with the folks who manage capital equipment before we move it to a new space or give it to another lab. So that's one of the things I meant to mention earlier as far as collaboration goes. We haven't had a problem with funders particularly complaining that it's not being used for what they intended, except for, because usually in this instance, it's not like a new piece of equipment that's going somewhere else. It's usually a lab that, the professor is retired, the equipment's been in use in its proper place for 10 years. So it's sort of at that point, then it's getting a second life somewhere else as far as that goes. And sorry, David, can you say what the first part of that question was? The first question was again?
It was just about how do you make this big and systematic, and I think leading towards, web-based approach.
Yeah, that one. I mean, that's tougher. Making it systematic is a challenge we face often, and that's why we have several different prongs to it. That's why we have the free cycle, so it reminds people, a big event. So maybe that's the kind of way that affects people best. There's a big event coming, great, I'll clean out and bring stuff down. Versus the reuse or the online version where somebody doesn't even have to do anything except take a picture of the object and post it online and wait for someone to come get it. Versus the reuse room where if they remember that they want to get rid of this at 3 a.m., they can take it downstairs and do it, because obviously researchers are in the lab at 3 a.m., fortunately or unfortunately. So I think, that's sort of our approach to sort of making, I guess, more systematic, is that we create opportunities across the board to meet researchers where they are. Trying to force one set system hasn't really worked for us yet. Although I know Harvard Recycling has tried many approaches as far as reuse on campus, and trying to make that web-based and easy for people to use, but we haven't hit upon something that's ideal yet.
Okay, great. Thank you very much. We are out of time. Just briefly in wrapping up, I would like to mention another opportunity to hear the illustrious Bill Spratt from WPI in a little over a month's time in Portland at the ASHE conference. He's going to be on panel Making Greener Labs Programs of Value Add that we'll be moderating. And in addition to Bill, there will be representatives from Brown University and the University of California system. So go check that out if you're interested. It's on October 28th. And if you have any other questions, or you want to talk further about approaches to greening your labs, email us. We'd love to follow up with you. And thank you very much. Thanks, presenters, and thanks for all the attendees for an interesting webinar.